Hey, what's up, chat? Welcome to Unit 9, Day 5. This is the last and final lesson in this unit, and we are going to be comparing and contrasting different probability of independent and dependent events, okay? And so over the last several lessons, we talked about what are the differences between independent and dependent events. We have found the probability, and this time in today's lesson, we are going to be comparing them, okay? And so here's the big idea, all right? If the scenario is the same, but one is independent and the other is dependent, which has the greater probability of a certain outcome, okay? And so if the scenario is the same, one's independent, one's dependent, which one is gonna have either a greater chance or maybe, and sometimes the question might ask the least probability of something happening, okay? And so we're going to start with the examples that we started with at the very beginning of this unit, all right? We got Jill. She has some marbles. She's going to pick one at random. It tells us that she has 5 green. She has 9 red. She has 6 blue marbles. And then in this first scenario, she is putting it back, all right? So we got 9 green, 6 blue, and she puts it back, and then she picks another marble. So that is our situation. What is the probability of selecting a red marble followed by a green marble? Okay, so we are looking for the probability of selecting a red marble times the probability of selecting a green marble. And the key is, right, she puts it back. So because she puts it back, that is independent, right? So she is putting it back. So the first, selection will not affect the second one because she put it back. I'm still going to have the same number of marbles, okay? And so the probability of getting a red is 9 out of the total is 20. Okay? And then the probability of getting a green is 5 green out of 20. Again, I still have 20 because she put it back, all right? And so then when I multiply these, okay, again, I can just use my Desmos calculator to multiply, and I'm gonna get 0.1125, all right, as my probability, okay? Now, same scenario, okay? She picks some marbles, still has 5 green, 3 red, 6 blue marbles, this time without replacement. That means she's not putting it back. Therefore, these are dependent events, okay, because she did not put it back. Then she picks another marble. What's the probability, again, of getting a red? And then the probability of the second one being a green, okay? And so, probability of getting a red is still 9 out of 20 because she has 9 red out of 20 total. This time she takes the marble out and she does not put it back. So therefore, we're going to lose one of our total. So now green, we have 5 green out of, now we have 19. Okay, because again, she just removed a red one. So therefore, the total has decreased. And now I plug this in, okay, and when I plug this into Desmos, I am going to get 0.1184, okay? And so, okay, again, my initial question was which one will have the greater probability? Okay. And if you look at these, right, they're similar to start. They both have 1s, but then the thousandth place in the second one is an 8, okay? So if you just think about these, just think about, in terms of, removing the 0 and looking at just the numbers behind the 0, this would be 1,125. This is 1,184. So therefore, we know that this one would be greater, okay? So I could answer, the question might say which is greater. Sometimes it might say which is the least, and then I would put this one. So I do have to read, but I'm just comparing and contrasting, right? They're not equal, right? This one's smaller than this one. This one's greater than this one, and that is how, again, we can answer different questions about it. But here's what I want you to see, okay? And this is kind of the answer to that question, right? When the events are independent, okay, they are going to have a lesser probability. Okay, they're going to have a lesser chance for those two events. Okay, and when they are dependent, they are going to have a greater probability. And as we saw, okay, the reason for that is because I am taking one away, and so I have one fewer outcome in the second event, so therefore my chances are going to be higher because I have less marbles left. Okay, so whenever you remove a marble, your probability goes up because you have fewer options, you have fewer outcomes, right? So a greater chance of getting that one. All right, so for the remainder of this lesson, I'm just going to cover two examples. All right, look, we've done enough of these. I think you could pause it and do the next one on your own. So go ahead and give it a try. All right, go ahead and pause it and then see if you can answer if you get it correct. All right, so Bailey randomly selects a marble from the bag, does not replace it, okay, and then randomly selects a second marble. Okay, so because we do not replace it, this is the dependent. Right. Kelly randomly selects a marble, she replaces it, therefore that's independent, okay, and then randomly selects a marble. Who has the least probability of selecting a green marble and then a blue marble? All right. So both of them are selecting the probability of selecting a green, then a yellow. Okay, they both selecting a green and then a yellow. Okay, who has the least probability? So we're trying to figure out which one is the least. All right, probability of getting a green. Let's look at Bailey's first. Probability of getting a green would be 10 out of the total. I have to add up all of these numbers. So 7 plus 10 plus 14 plus 19. Okay, when I add those up, I get 50. All right. Again, Bailey takes out the marble and does not replace it. This is dependent. So when she or he goes to get a yellow one, there's 14 yellow marbles, but because Bailey did not replace it, it is now 49. And so we can find an answer. You can plug that into Desmos and you will get, and I'm gonna round here, or actually I'm just gonna cut it off, 0.057. This does keep going, but we'll just get 3 decimal places, should be enough. All right, and then let's do Kelly. Probability of getting a green is 10 out of 50, right? Because there's 10 green, there's 50 total. This time, Kelly replaces it. Kelly puts it back, so therefore, I'm still gonna have 50, and I'm still pulling a yellow. Then I multiply those. The probability of getting a green then a yellow for Kelly is going to be 0.056. Okay. So now when I look at these two numbers, I'm looking for which number is the smaller number, right? Well, we have decimals. You can think about it just in terms of, not looking at the numbers in front of the decimal and thinking about it in terms of 56 and 57. And clearly we know that Kelly has a smaller probability. So who has the least probability? The answer here would be Kelly. And why? And here's the main part, right? Why is her chance lower, right? Why is her chances of getting a green then a yellow lower? Well, it's because after she pulled the green, she put it back, okay? And so because Kelly replaces the first marble, okay? And because she replaces it and puts it back, there are more chances, more outcomes. So it's going to be a smaller chance that she's going to get a yellow, all right? So again, the more chances that you have of something, the smaller the probability it is that you're going to get it, okay? And so that is, again, the reason why. The more, I think that's worth noting, okay? Let's write that in a different color. The more outcomes, the smaller the probability. Okay, and then it's a vice versa for, okay, when you have fewer outcomes, the greater the chance. Okay, so the fewer the outcomes, the greater. And again, this is just another way of sort of trying to make sense of why this is true, okay? And we've seen this throughout, all right? All right, we're gonna do one more and to just drive this point home, all right? So, hey, I'd love for you to go ahead and try to do it on your own, and then you can use this to check your answer. All right, so Michelle replaces, all right, then gets a second card. Darren selects one card, does not replace it, okay? So this is independent because we're replacing it. Darren's is dependent because did not replace it. What's the probability? I'm sorry, who has the greater probability of selecting one blue card and one yellow card, all right? So we're looking for the probability of getting a blue and then the probability of getting a yellow. Okay, same thing for Darren, probability of getting a blue times the probability of getting a yellow. Okay, and then we're figuring out who has the greatest, right? So probability for Michelle is 4 because there's 4 blue. All right. All right, 4 blue out of the total. 3, 5, 4, that's 12. Okay. So 4 out of 12 times, what's the probability of getting a yellow after she replaces it? So Michelle puts it back. I'm still gonna have 12 over, and I know this is getting jumbled. There's 5 yellow. Okay, so it's 4 over 12 times 5. Let's rewrite that. You can write it over here. Yours is probably, it's fine. 4 over 12 times 5 over 12. Okay, 4 over 12 times 5 over 12, and that's gonna give me 0.138, and then that 8 just repeats. All right, and then let's go again. Let me make mine a little smaller. 4 12s. Okay, and then the probability of getting a blue is going to be 4 over 12. Again, that's the total. This time, Darren is not replacing it, so takes the blue card out, does not replace it. So now I'm going to have 11 cards left, right? And then the probability of getting a yellow is 5. And so then when I multiply these, 4 12ths times 5 11ths, that is going to give me 0.151515. It just repeats. Okay. So who has the greater probability? Who has the greater probability of getting one blue and one yellow? Well, the answer is Darren. All right. Darren has a greater probability of selecting one blue and one yellow because they do not replace the card. And have fewer cards on the second pull. Okay, so there you have it. All right, In this lesson, we have learned to compare and contrast independent and dependent events. All right. Hey, let me know if you have any questions, and we out.